Welcome to the deep dive. Today, we're aiming to cut through, the complexity and the jargon. Our mission really is to give you a shortcut, a concise, clear path to understanding these critical concepts from the fundamentals right up to the cutting edge stuff.
And our sources for this deep dive, it's pretty comprehensive collection of articles, research papers.
Mm.
We've really dug into the journey from those, let's say, traditional data warehouses all the way through data lakes, data lake houses, and even the really transformative data mesh concept. We've basically tried to distill the most important insights, maybe some surprising facts, just to help you quickly grasp the essence of each big shift in architecture.
If you've ever built an application or maybe wrestled with a data set yourself, you've probably hit that fundamental question. Where does all this information actually live? And I mean, how do companies, whether they're tiny startups or huge global enterprises, actually make sense of the absolute tidal wave of data they're generating every single second? For a programmer or really anyone interacting with data, choosing the right place, the right strategy for your information, it's not just technical, right? It can feel
Yeah.
totally overwhelming. So, yeah, we're here to try and demystify that choice for you.
hmm And what's truly fascinating here is the fundamental shift we've seen, especially over the past, say, couple of decades. Data isn't just a byproduct of operations anymore. Not at all. It has profoundly transformed into this vital asset. It's literally fueling decisions, driving innovation, shaping customer experiences. The core problem, the thing that really kicked off this whole architectural evolution, was the sheer volume, velocity, and variety of data. What we'd often call big data. The
Mhm.
traditional systems, they just couldn't keep up. Simple as that.
Right. Think about maybe your earliest attempts at organizing information. You probably had like a well-organized bookshelf, a specialized library for all your structured books, everything perfectly cataloged, maybe neat rows and columns if you were really organized.
But its design was strictly for structured data. Think spreadsheets, relational databases, data that fits nicely into predefined rows and columns. And a core engineering principle here was something called schema on write. This means the structure, the format, the relationships of the data. All that must be defined and stick to a strict blueprint before you can even store it. Now, this rigidity, it ensured consistency. It made querying really efficient for that structured data. But yeah, it came at the cost of flexibility.
So hang on. You literally had to know exactly what kind of data you were getting and how you plan to use it before you could even put it in the warehouse. That sounds incredibly restrictive, especially now when new data formats seem to pop up like daily.
Is restrictive, yeah. And the process to get data into the system, because typically ETL, extract, transform, load. So data was pulled from various sources, then it was transformed into that predefined consistent format, and only then was it loaded into the warehouse. Now, as data grew exponentially, not just in volume, but especially in variety, like images, video, sensor readings, social media feeds, all that unstructured stuff, the CTL process, it became a monumental bottleneck. It was slow, it got incredibly expensive to scale, and critically, it just wasn't designed for storing the raw granular data you often need for, say, advanced analytics or machine learning. If your goal was to just experiment with data you didn't fully understand yet, the data warehouse, yeah, it was basically a non-starter.
Okay, so our trusty old library, excellent for its specific purpose, but it just couldn't keep up with the diverse, chaotic, explosive growth of modern data, which definitely raises the important question. If the old way wasn't cutting it anymore, what innovations stepped in? What came next to tackle this new era of data? Moving from that kind of rigid centralization towards more flexibility and eventually something quite profoundly decentralized. It seems like a progression driven purely by necessity.
The first major leap forward was the data lake, the unfiltered reservoir. This concept emerged pretty much directly to tackle the data warehouse's struggles, particularly with unstructured data and scalability. A data lake is essentially a centralized repository designed to store just vast amounts of raw data, and crucially, in its native format. So whether it's structured, semi-structured, or completely unstructured, you just put it in. Think of it less like that curated library and more like a massive, incredibly inexpensive digital reservoir where you just dump all your data. No prior cleanup, no initial organization needed.
Okay, so it's like throwing all those random notes, audio recordings, videos, everything into one giant digital box, no questions asked. That
Yeah.
sounds incredibly liberating, I guess, but also potentially really chaotic.
Its core strength, though, lies in leveraging very cost-effective cloud object storage. Think Amazon S3, Google Cloud Storage, Azure Blob Storage. It's like an infinitely scalable, incredibly cheap digital dumping ground in the cloud, perfect for raw files, whether you're talking terabytes or petabytes. And crucially, data lakes really introduce the separation of storage and compute. This means you can store, say, petabytes of data without having to buy equally massive, always-on processing power right up front. You only sort of rent the computing muscle when you actually need to analyze specific parts of that data. And instead of ETL, they kind of flip it to ELT. Extract, load, transform. Data is loaded raw, completely untouched, and transformations happen only when needed for a specific analysis. This is enabled by schema on rate. The schema is applied at the time you query the data, not when you store it.
That flexibility sounds revolutionary,
Yeah.
honestly. But with all that raw data, no predefined structure, just dumping it all in, my programmer brain is kind of screaming, data swamp. How quickly can that unfiltered reservoir become completely unusable if you're not careful?
You've absolutely hit on the critical challenge. Without proper cataloging, without good metadata, without quality control processes, data lakes can very quickly devolve into these infamous data swamps. Maybe you're trying to build, I don't know, a product recommendation engine, only to find that customer data in your lake is just riddled with duplicates, half-filled records, because nobody really owned its quality when it was ingested. That's the real cost, the hidden danger. They often struggled with robust data governance, security wasn't always straightforward, and just querying large volumes of raw, unstructured data. That could lead to performance issues, especially if the users lacked specialized big data skills. As the name suggests, this is really a hybrid approach. It aims to combine the flexibility and the cost efficiency of data lakes, but with the reliability and the performance characteristics you'd traditionally find in data warehouses.
Ah, okay. So going back to our analogy, it's like our giant digital box of raw data, but now we're putting like a smart catalog system and a high performance retrieval system directly on top of it. So you can still access things efficiently, even if they're in their original, maybe messy format.
It builds directly on the data lake storage layer, so you're still using that cost-effective cloud object storage,
Yeah.
but it adds a crucial metadata layer. And this layer, it's the real game changer. It brings really powerful capabilities like enabling ACID transactions. Okay, that means you can now perform operations on your data lake, updates, deletes, merges with the same kind of rock-solid reliability and consistency you expect from a traditional database. It prevents data corruption, avoids errors, even when multiple processes are hitting the data at once.
Wow, okay. That sounds incredibly powerful. So you can dump raw data in, keep that flexibility, but then you can impose structure when you need it. And even run reliable database-like transactions on it all at scale. Almost sounds too good to be true. Are there any scenarios where, say, a pure data lake or a classic data warehouse would still clearly outperform a lake house, or is it really becoming the universal solution now?
Well, it's incredibly versatile, but maybe not quite universal yet. A pure data warehouse might still offer slightly lower latency for very rigid, high-volume BI queries, just because of its highly optimized pre-index structure. It's built for that one job. And a raw data lake still probably reigns supreme for pure, unadulterated data experimentation when you absolutely don't want any structure imposed initially. However, the Lakehouse leverages optimized query engines, think things like Apache Spark, Presto, Trino, and these offer performance for analytical queries that's often comparable to, or sometimes even better than, many traditional data warehouses. Plus, it seamlessly supports both batch processing and real-time streaming data, which is huge. The benefits are pretty clear. Cost-efficient storage, vastly improved data quality and governance compared to our raw data lake, handling diverse data types in one single platform, and yeah, often faster query performance for many analytical uses. And the key technologies making this possible are these innovative open source table formats. You might have heard of Apache Iceberg, Delta Lake, Apache Hudi. They essentially add that transaction layer, schema evolution, and enforcement directly onto the raw data file stored in your lake.
Okay, that seems like a really logical progression, solving one problem after another. But what if your organization is truly massive? Like data spread across countless different departments, different business units, each with its own unique needs, its own way of working. It feels like even a powerful lake house could eventually become a bottleneck if everything still has to funnel through some central data team, right?
And it leads us to the latest and perhaps most radical shift, the data mesh, the decentralized network. This is a newer paradigm, really a fundamental shift, that directly addresses the scaling challenges faced by even the largest centralized data platforms, whether they're lakes or lakehouses. Instead of one big central repository that everyone feeds into and pulls from, it distributes data ownership and responsibility out to individual business domains. Think of it less as a single place where data lives and more like a network of interconnected data products, where each product is managed by the team that understands that data best, almost like they're running their own mini data-focused product team.
Whoa. Okay, so it's less about a single piece of technology, like a specific database or platform, and much more about a fundamental organizational and, I guess, cultural shift. Each department, like marketing or sales, effectively becomes its own mini data company, responsible for producing and managing its own data products for others to use. That sounds like a major undertaking.
It's built on four core principles, which really define it. One, domain-oriented decentralized data ownership. The teams closest to the data say the marketing team owns the marketing campaign data, the sales team owns the CRM data. They're responsible for its entire life cycle. Quality, security, availability. This ensures much better data quality and relevance because the experts who live and breathe that data every day are the ones managing it. Two, data as a product. This is key. Data assets are treated just like any other software product. They need to be discoverable, addressable, trustworthy, secure, and ultimately valuable for their consumers, who are often other internal teams. This forces a real product mindset onto data creation and sharing. Three, self-serve data infrastructure as a platform. Here, central IT or data teams shift their role. They don't manage all the data pipelines or transformations anymore. Instead, they provide the tools, the platforms, the infrastructure that empowers those domain teams to build, deploy, and manage their data products independently. This drastically reduces central bottlenecks. And four, federated computational governance.
Now, while it's decentralized, it's not chaos. There are still global standards, policies, rules for security, interoperability, quality that ensure consistency across the entire mesh. But domains have local autonomy within those global guidelines to implement them in ways that make sense for their specific data.
Okay, this definitely sounds like it could massively improve business agility, maybe speed up insights, especially in those really large, complex organizations you mentioned. But what are the main hurdles, the trade offs? It can't be all easy, beyond just the big cultural shift.
The benefits are compelling, no doubt. Improved agility, potentially faster time to insight, increased scalability by removing those central choke points, and often enhanced data quality because of that direct domain expertise. However, the challenges are significant. First, as you said, it requires a truly fundamental organizational and cultural shift. That is never easy and takes time and commitment from the top down. There's often a high initial overhead in setting up the self-serve platform and educating all the domain teams on their new responsibilities. Ensuring true consistency and interoperability across dozens, maybe hundreds of disparate domains can be incredibly complex to govern effectively. And there's also a real potential for skill gaps within those domain teams who now suddenly have substantial data engineering and data product management responsibilities they might not have had before. It's definitely less about just installing a new piece of software and much more about fundamentally rethinking and reorganizing your entire data strategy.
Okay, right. So here's where it gets really practical, hopefully for you, the programmer listening. Trying to figure out, okay, which of these tools is right for my job or my company's job?
Mhm.
How do you even begin to choose between these different evolving architectures? It's clearly not a one size fits all kind of answer, is it?
The right choice depends entirely on your specific needs, the nature of your data, your team skills, and yeah, your organizational structure and scale, based on what we've discussed. The data warehouse. It's still probably ideal for traditional business intelligence, BI, fixed reporting, things where you primarily deal with structured historical data and your analytical questions are pretty well defined up front. Perfect for generating your standard monthly sales reports, for example. Then the data lake. This is really best for data exploration, for advanced analytics, machine learning, AI projects, anywhere you need that raw, granular data of diverse types, especially when the structure of the schema isn't known up front or might change. It's fantastic for experimentation. Like say you're building a brand new fraud detection model and you just need to ingest every piece of raw transaction data you can get your hands on, structured or not. The data lakehouse. This is becoming increasingly popular for what's called unified analytics. It brilliantly blends the best of both worlds, supporting both BI and MLAI use cases. It handles structured, semi-structured, unstructured data all in one platform. This is often the choice when you need the flexibility and the cost efficiency of a data lake, but you also need the reliability, the governance, the ACID transactions, and the query performance that used to be associated only with data warehouses.
It's great for things like building a unified customer view, maybe combining structured CRM data with unstructured web clickstream data for better personalization. And finally, the data mesh. This approach is really best suited for those large, complex organizations, companies with many diverse business domains where agility, decentralization, and domain-specific data ownership are absolutely paramount. It's not just a technical choice. It's a deep organizational and architectural paradigm shift. It's for companies really looking to empower their teams and scale data usage way beyond what any centralized platform could handle. Imagine a global enterprise with dozens of distinct product lines, each needing rapid, reliable access to its own data and potentially data from other domains.
Got it. So it's not just about the tech stack itself, is it? It's deeply intertwined with the scale of the data, the structure of the teams using it, and the overall business goals you're trying to achieve.
Precisely. So, when you're making this decision for your project or your company, you need to critically consider how big and complex is your data landscape, really? What are your specific business needs and use cases? Are you focused mainly on traditional BI, real-time analytics, cutting-edge AI, all of the above? Think hard about your governance and security requirements. How strict do they need to be? What's your existing infrastructure look like? And crucially, what are the skill sets and the culture of your team? Can they support the chosen architecture? The best architecture is always the one that aligns synergistically with all these different factors.
What stands out to you about how these choices stack up? As you're listening, how might you apply some of this thinking in your own projects or your workplace?
This whole journey, from those classic data warehouses right through to the decentralized data mesh, it isn't just about the technology changing. It's fundamentally about how organizations are adapting, how they're learning to cope with, and hopefully leverage the truly overwhelming amount of data they now possess. It feels like a continuous balancing act, doesn't it? Between centralization and decentralization, between structure and flexibility, between having tight control and giving teams more autonomy. Each step in this evolution we've talked about has really tried to solve the limitations of the previous one, constantly pushing for more scalable, more flexible, and ultimately more accessible ways to harness information and turn it into value.
It really is a strategic decision, isn't it? Not a one-size-fits-all technical fix. And it's one that needs to keep adapting as business needs evolve and, of course, as technology continues to advance at breakneck speed.
Mhm.
How do you see your role evolving in this data world? What kind of data challenges are you most excited or maybe even a little intimidated to tackle with some of these new architectural tools and approaches? Thank you so much for joining us on this to deep dive into the world of data architectures. We really hope you feel a little more equipped and maybe a lot more curious to navigate this ever changing landscape.